So let's discuss the next concept of factoring, which is using patterns. We're going to talk about the difference of squares, the sum and difference of cubes. And so let's look at the difference of squares first. So it's important to keep in mind the words difference. Means whenever we're discussing the difference of squares, the problem is a subtraction problem, or you need to be able to express the expression as a subtraction problem. So that's the difference. If it's not a subtraction problem, then we can't use this to factor. Squares. What are squares? Squares, when we're discussing this particular topic, refers to some value that was multiplied times itself to give you an answer. So in other words, when I look at 2 times 2, that equals 4. So 4 is a perfect square because we got 4 by multiplying a value times itself. X times x is x squared. So x squared is also a perfect square because we multiplied x times itself to give us that product. So when we're identifying the difference of two squares, it needs to be the subtraction of two perfect squares, similar to the x squared and 4. So once we've identified it as a difference of two squares, in order to factor it, we break it down into the value that was multiplied times itself. So a times a gave us the a squared. And our second terms would be the value that gave us the second term, the b squared. So that's b times b. Notice again, since it's a subtraction problem, one of the factors has to be positive and the other has to be negative. So let's look at the first example, x squared minus 9. Is this the difference of two squares? So it met the first criteria that it's a subtraction problem. And also we know that x squared is a perfect square because x times x gives us x squared. And 9 is a perfect square because 3 times 3 gives us 9. Before we get into the factoring, remember that anytime we are asked to factor, our first step is to remove the greatest common factor. So in some cases, when you first look at the problem, they may not be perfect squares. That may be because we need to remove the greatest common factor first. So in this case, again, nothing divides into x squared and 9. We've already identified it as the difference because of it being a subtraction problem. And x squared and 9 are both perfect squared. So now we just go directly into the factoring. So how do we get an x squared? We get an x squared by multiplying x times x. How do we get a 9? We multiply 3 times 3. In order for the product to be a minus 9 or a negative 9, one of our factors has to be positive and the other negative. Remember, order doesn't make a difference. So the next problem, 64x squared minus 1. What we're going to look for first is see if anything divides evenly into 64x squared and minus 1. Nothing does. So now we see a subtraction problem. So that meets the criteria of being the difference. 64 is a perfect square as well as x squared. And 1 is a perfect square because we can get that by multiplying 1 times 1. So again, we go directly into our factoring. We know that 8x times 8x gives us 64x squared. We know that 1 times 1 gives us 1. And we know one factor has to be positive and the other factor negative. So our next example, we have x squared plus 4. The first thing we look for is the greatest common factor. Nothing divides evenly into x squared and positive 4. So now we know that x squared is a perfect square and 4 is a perfect square, but it's separated by a plus sign. Therefore, it is not the difference of squares. It doesn't meet the criteria. Since we couldn't take out any value, there's no greatest common factor with the exception of 1. So that means this is not factorable. Or again, we call it prime. The next example, 50x squared minus 18. So our first step in all factoring problems is to remove the greatest common factor. We know they're both even numbers, so we know that 2 can go into both of these values. So when we factor out a 2, 50 divided by 2 is 25, so we get 25x squared. And negative 18 divided by 2 is a minus 9. Now, we test this to see if it meets the criteria for the difference of squares. First of all, it is the difference. It is a subtraction problem. We know that 25x squared is a perfect square. That's 5x times 5x. And we also know that 9 is a perfect square, 3 times 3. So we're going to write down our greatest common factor, which was 2. And now we're going to follow the pattern to factor the difference of two squares. So we know 5x times 5x gives us the 25x squared. We know 3 times 3 gives us 9. We know one of our factors has to be positive and the other negative. The next concept we're going to discuss is factoring the sum of cubes and the difference of cubes. So sum, S-U-M, refers to addition. So that means we can use this when we're adding perfect cubes. And it also has difference of cubes as a possibility. And so it doesn't make a difference if it's a plus or a minus sign separating. So the whole thing behind this is being able to recognize the sum and difference of cubes. So if we can identify it, then we're just going to follow the pattern. So what I'm going to do is look at a problem and show you how the pattern works. So here we have x cubed plus 64. What's my clue that this would be the difference of cubes and not having to worry about squares? Well, 64 is a perfect square, but if you pay attention to the exponent, this exponent is 3. When the exponent is 3, that means cube. So what we're looking for here is what multiplied times itself 3 times gives us these particular terms. So our first step, since this is the sum of cubes, we're going to use the first formula. Notice it starts as a cubed plus b cubed. So what we're going to do is break it down into the values that were cubed that give us those particular terms. So this is x cubed, because we know x times x times x gives us x cubed. And 64 is 4 cubed, because 4 times 4 is 16, times 4 is 64. Okay, so now we've done step number 1, and that's to identify what cubed gives us each one of these particular terms. Now notice, we're going to label these A and B just to follow the formula. So I'm going to put an A above the X and a B above the 4 so that you can follow the formula. So once we've identified what cubed gives us each term, we can go to our first factor, and that's this binomial, these two terms that are in parentheses. And what it says to do is take A plus B. Well, we just found A to be X and B to be 4. So again, just following the formula, whatever's inside parentheses in your first step are your A and B. And so that makes up your first factor. Notice that I have a plus between the X and the 4. That's because my original problem was the sum. Next, I follow the pattern to write my trinomial. So if you look inside the formula, that first term in the trinomial is a squared. So what I would recommend is coming back to your a, which in this case is the x, and multiplying it times itself. Instead of saying squaring it, just say this a value times itself. So x times x is x squared. Notice the sign. The next sign is minus. And our next term is multiplying a times b. So when I multiply x times 4, I get 4x. Notice your next term has a plus sign and it says b squared. But remember, instead of saying squaring it, it's going to be easier in the long run if you say I'm going to take the b and multiply it times itself. So in this case, b is 4 and 4 times 4 is 16. So all you're doing to factor the sum and difference of cubes is to follow the pattern. Okay, let's do another one. So again, I know I've said it a million times, but the first step in all factoring problems is to look for the greatest common factor. Nothing divides into 8x cubed and 1. So we can go on to our next step. So again, we're looking at our exponent 3, which is going to be a clue that we're going to deal with the sum or difference of cubes. Since it's a minus, it's going to be the difference of cubes. So the first step is to decide what times itself 3 times gives us each one of our terms. So I know to get an 8, that's 2 times 2 times 2. And of course, to get an x cubed, it's x times x times x. So that would be our A. To get a 1, it's 1 cubed because 1 times 1 times 1 gives us 1. And we're going to call that B. So let's follow the formula. So we've done step number 1. Now our first factor is A minus B. Well, A is 2x and B is 1. So why do I have a minus sign in between? Because this started out as a subtraction problem. Next, I just follow my pattern to fill in the trinomial. So the first thing I do is take A and multiply it times itself. So A is 2x. So when I multiply 2x times 2x, I get 4x squared. So my next step, I multiply A times B. What sign do I use? Plus. So the sign I started with the minus and this middle sign are always opposite of one another. So my next term is A times B. So A is 2x, B is 1, so 2x times 1 is 2x. My last term is multiplying B times itself. Since B is 1, I multiply 1 times 1, and it gives me 1. This last term is always positive because you're multiplying a value times itself. Next example. First step in all factoring is to remove the greatest common factor. Nothing divides into all of these. So I go to step number 2. I'm going to know that this is possibly the difference of cubes because my exponents are 3. So the first step is I decide what cubed gives me each one of these. So to get a 27, that's 3 times 3 times 3. And an x cubed is x times x times x. To get a 125, that's 5 times 5 times 5. And to get a y cubed, that's y times y times y. So again, I'm going to label these A and B so that I can follow the pattern. So in order to follow the pattern, remember my first factor is A minus B. So A is 3x and B is 5y. Why do I have a minus sign? Because the problem starts out as a subtraction problem. Next, I follow the pattern for my trinomial. So in order to get my first factor, remember it's A times A. So when I multiply 3x times 3x, that gives me 9x squared. My middle sign is always opposite of what I started with. Since I started with subtraction, this is going to be addition. And that term is found by multiplying A times B. So when I multiply 3x times 5y, that gives me 15xy. Again, following the pattern, this is always plus because I'm multiplying a value times itself. So I'm going to take the b, which is 5y, and multiply it times itself. So 5y times 5y is 25y squared. So all the sum and difference of cubes is following that pattern. So next we're going to find roots. So what are roots? Roots are the solution to an equation. in this case, a quadratic equation. So in quadratic equations, for this particular unit, we're just going to use factoring to solve. So what we're going to look at is the zero product rule first. So the zero product rule means that when I'm multiplying two values together, if the product is zero, either the first factor is zero or the second factor is zero. Because if either one is zero, zero times anything will give you zero. So what do we do to solve these problems? Step number one is make sure we set the equation equal to zero, which we have in this first example. Step number two is to factor using whatever method is applicable. So here we have x squared minus x minus 56 equals 0. Our leading coefficient is 1, so we can use our shortcut. So our shortcut is we're looking for the factors of negative 56 that add to our middle term, which in this case is negative 1. So we know that negative 8 times positive 7 is negative 56, and negative 8 plus 7 equals negative 1, which is our middle term. So we can factor this to x minus 8 and x plus 7. Now we're going to use the zero product rule to finish solving. So we're going to set our first factor equal to 0 and solve, and our second factor equal to 0 and solve. So in the first one, I'm going to add 8 to both sides. So one of my solutions is 8. And so the second one, I set to 0 and solve. And so my second solution is negative 7. So, so whenever we're solving these problems, if we look at our exponent 2, that will tell us how many possible solutions there are. So in this case, we had 2 possible solutions, and they are 8 and negative 7. Our next problem, again, we're solving quadratic. So the first thing we do is set it to 0. It's already set to 0. So my next step is to factor. So my first step in factoring is to remove the greatest common factor. So in this case, it's x. So I'm going to remove an x, and that's going to leave me 5x minus 8. So again, I have 2 solutions because that told me in the first place when I had an x squared. So I set each one to 0. So x equals 0 and 5x minus 8 equals 0. So one of my solutions is 0, and now I solve for the second one. So this gives me 5x equals 8. So I'm going to divide each by 5. So my second solution is 8/5. So my 2 solutions would be 0 and 8/5. Next problem, 7x squared equals 12x minus 5. So remember, your first step is to set the equation to 0. So I need to move the 12x and the negative 5 from the right-hand side to the left-hand side. And the way you do it, the easiest way to do it is to take the opposite. So on the right-hand side, the 12x is positive. So when I move it to the left-hand side, it becomes negative. The 5 is negative on the right-hand side. So when I move it over to the left-hand side, it becomes positive. So now I have 7x squared minus 12x plus 5. I know I'm going to have 2 possible solutions. So I'm going to use the AC method to factor. So remember, your first step in factoring is to move the greatest common factor. Your next step is to multiply the A times the C. So I'm multiplying 7 times 5, and that gives me 35. I'm looking for the factors of 35 that add to a negative 12. So my factors of positive 35 are 1 and 35, negative 1 and negative 35, 5 and 7, and negative 5 and negative 7. So this gives me a 36, a negative 36, a 12, and a negative 12. Since my middle term is negative 12, I use the negative 5 and -7 to rewrite my expression. So I have 7x squared minus 5x minus 7x plus 5 equals 0. So next, I factor by grouping. Remember, you take sign and all in the second grouping. So in the first group, the greatest common factor is x. When I take out an x, that leaves me 7x minus 5. In my second group, remember, whatever the sign is, in this case, it's minus. So the only thing that divides into 7 and 5 is 1. So when I take out a minus 1, remember, that will change the sign. So this becomes 7x minus 5 equals 0. My greatest common factor is 7x minus 5. And the two factors on the outside make up the other factor. My last step is to use the zero product rule. So I'm going to set 7x minus 5 equal to 0 and solve, and x minus 1 equals 0 and solve. So I'm going to add 5 to both sides. So 7x equals 5, and I'm going to divide by 7. So x equals 5/7. For my second one, I'm going to add 1 to both sides. So this gives me x equals 1. So my two solutions would be 5/7 and 1. My next example, I start with x cubed. So that tells me I have 3 possible solutions because my highest exponent is 3. X cubed plus 11x squared plus 30x. So what is my first step in factoring? It's to remove the greatest common factor. Since they all have an x, I'm going to remove an x. So when I do that, that gives me x squared plus 11x plus 30 equals 0. Okay, so now I'm going to look at what's inside the parentheses, the x squared plus 11x plus 30. Since my leading coefficient is understood to be 1, I can do the shortcut. So here I'm looking at my factors of positive 30 that add to an 11. So I know 6 times 5 is positive 30, and 6 plus 5 equals 11. So I can go directly into my factoring. So I still have the x on the outside. Now my two other factors would be x plus 6 and x plus 5. Again, because 6 times 5 is 30, and 6 plus 5 gives me 11. So my last step is to set each one of these to 0 to solve. So I have x equals 0 as one of my answers, x plus 6 equals 0, and x plus 5 equals 0. So I'm going to subtract 6 from both sides. So x equals -6, and then I'm going to do the same with the 5. So I'm going to subtract 5 from both sides, and that gives me x equals -5. So my 3 solutions would be 0, -6, and -5.